Okay, so number 2 is set up in vertex form for us, or standard form. G of x equals -3 times parentheses x plus 2 close parentheses squared plus 4. Find the y-intercept of the graph. So remember, we can't just say whatever that constant hanging out there is. We have to plug 0 in for x and actually calculate that out. I'm going to go quicker through this one. If you want to try it on your own, go for it. But I will try to go a little quicker through. -3, so we're finding g of 0 equals -3 times 0 plus 2 squared plus 4. So we would get -3 times 2 squared, which would be 4, plus 4. And then we get -12 plus 4 would be -8. So g of 0 equals -8, and we tend to write that as a point. So the y-intercept is the point 0, -8. Okay, so that's our answer for part A. Part B, find the vertex of the graph. Well, that's really nice because we have it in vertex form. And remember, the generic is f of x equals ax minus h squared plus k. So I know the vertex is hk, right? So in this case, h is plus 2, but remember, because this subtract x minus h is what the format is. So I'm just going to pull this out. So actually x plus 2 would be x minus 2. So therefore h equals -2. So h would be -2 and k is just plus 4. That's our vertex. That is a nice quick method there. C, find the x-intercepts of the graph, and you can do that using the square root method. That's great review for you guys. Just set g of x equal to 0 and put in your function there. And then you're going to subtract 4, divide by -3, and take the square root of both sides. So pause the video and try that. Okay, so I'm going to subtract 4 here. So we end up with -4 equals -3x plus 2 squared. Divide both sides by -3. And then I end up with 4/3, which is good because I need to take the square root here, equals x plus 2 squared. And then I'm going to take the square root of both sides. Make sure you do plus or minus. So then I can kind of subtract the 2 at the same time if you want. So I would get -2 plus or minus the square root of 4/3 equals x. Then typically I want to rationalize that denominator, so I would multiply top and bottom by square root of 3, and then I would get x equals -2 plus or minus, I would have a square root of 12 in the top over 3. Then I would want to simplify that square root of 12. A little review there for radicals, plus or minus. That would be the same as 4 times 3. I could take the square root of 4, would be 2. So I have 2 square root of 3, all divided by 3. And you can leave it like that as its simplest form. Sometimes you have to put it in as points. You could also get a common denominator over here of 3, and you could have -6 plus or minus 2 square root of 3 all divided by 3 like that. Would be okay too. So now we have an interesting question here. When does the graph of G intersect L of X equals 3x plus 4? So we could do this a couple of different ways. We could graph each one and then look at our graph. If we wanted a precise answer, though, we'd need to find it algebraically. And the way to do that would be to just write out your G of X. So you would want to know, when does G of X equal L of X, right? So I would set them equal to each other. So G of X is negative 3x plus 2 all squared plus 4. L of X is given right here, 3x plus 4. And then I would crunch the numbers all up. I would set that, well, I could do it a number of different ways. I think I did this one. Yeah, I expanded everything out, and I would then factor it and get those x values where it intersects. But then you have to plug those x values into one of the functions. So you're not done, because it's not actually where the 0 is. It's what that x value is going to give you on that function. So I'll work through that with you, but if you want to pause the video and try that, go for it. Another way to do, and I'll tell you, kind of put your y-axis maybe more off to the right on this one, but you could graph it as well and see where that ends up. So I'm gonna put it maybe like this. So the x-axis is a little high and the y-axis is kind of off to the right. And then you can plot those points too, so you can see how it fits, all fits together. Okay, so hopefully you tried this. You're going to expand out this x plus 2 squared, and you'll get x squared plus 4x plus 4. Then we have to distribute that negative 3 to all of that. So we get negative 3x squared minus 12x minus 12. And then the plus 4 equals 3x plus 4. So then we go ahead and just combine like terms. So the negative 3x squared, I have negative 12x squared minus 3x is going to give me minus 15x. Negative 12 plus 4 gives me a negative 8, and then I subtract 4, I get minus 12, and I set that. That's all equal to 0 now. So then I can factor out a negative 3. So let's go ahead and do that. Negative 3 x squared plus 5x plus 4 equals 0. And it's really like I divide both sides by negative 3, and I'm just left with the x squared plus 5x plus 4, and I factor that is x plus 1 x plus 4 equals 0. So I have x equals negative 1 or negative 4. So once I get there, I have to plug back into one of my functions to get the corresponding y. So I'm actually going to plug back into the L of x. So I'm going to find L of negative 1, which will be 3 times negative 1 plus 4. And that gives me negative 3 plus 4, which gives me 1. And the reason I'm doing that is because it's easier. It's much less complicated. So then I have L of negative 4 is 3 times negative 4 plus 4. I mean, you could really just do this in your head. Negative 12 plus 4 is going to give us negative 8. So our points, our actual answer, points of intersection are negative 4, negative 8, and negative 1, 1. So that's our answer. And we can look at how that lays out for our graph as well. So go ahead and pause the video and try to graph the parabola, which is the function. I'll just write that off to the side here. So we're going to graph g of x equals negative 3x plus 2 squared plus 4. And we're going to graph L of x. So we're going to graph these two and then see how they relate to one another. So go ahead and try that. Okay, so before I started plotting dots, I wanted to figure out what this X-Intercepts, what those were actually out as decimals. So I just crunched the numbers in my calculator and I got negative 0.845 and plotted this dot here. And then I got negative 3.155 for the other one. So I also plotted my vertex that I found earlier and my Y-intercept that I found earlier. So then I'm going to just connect those. That's kind of a skinny one. And then I'm going to plot the 3x plus 4. So I'm going to do that in a different color here. So 1, 2, 3, 4. And then up 3 over 1. But I also could go down 3, left 1. Down 3, left 1. So I get this line, it's linear. I want to extend that down. Now mine's not going to be super accurate because I'm not using a straight edge, but negative 4, negative 8 is where I should have my intersection. 1, 2, 3, 4. And then down at negative 8. So I need to draw my graphs a little bit better. So this helped me set my lines up a little bit better. That's why doing it algebraically is really critical. Or you could use technology. You could use Desmos. But I know that has to intersect right here. So make it look a little bit better. And then I also had it coming through negative 1, 1 was my other value right here. So I'm going to fix this pink line. Kind of goes like that. Okay, so in Desmos, if we were to do this, it would come out a lot better. But just to give you an idea of how those fit together, that's a system of equations. And drawing by hand is kind of challenging to get it where you want it to go. But we will use technology for that. So that's it for this one, and have a great day.